In this video, we're going to look at some trig integrals where the powers of sine and cosine are even. So we have integral sine x to the power of m times cosine x to the power of n integrated with respect to x. If both m and n are even, we use half-angle identities. Cosine squared x is equal to 1/2 times 1 plus cosine 2x, or sine squared x is equal to 1/2 times 1 minus cosine 2x. Here we have the definite integral from 0 to pi over 2 cosine squared x dx. We begin by applying the half-angle identity. So let's rewrite the integrand. Integral from 0 to pi over 2 cosine squared x, that's 1/2 times 1 plus cosine 2x integrated with respect to x. Alright, we can pull the 1/2 to the front and integrate term by term. So what we have is 1/2 integral of 1. What is antiderivative of 1? That's just going to be x. And what is antiderivative of cosine 2x? That's going to be sine 2x divided by 2. This is just reversing the chain rule, or you can say we're doing the substitution technique. And we're going to show that at the end in terms of how we're doing that. So that's evaluated from 0 to pi over 2. So we have 1/2, applying the fundamental theorem of calculus, put pi over 2 in, we get pi over 2, plus sine. We have 2 times pi over 2, well the 2's cancel out, we just get sine of pi, divide by 2, minus, substitute 0 in, we get 0 plus sine 0, divide by 2. Now sine of any multiple of pi will be 0. Sine of pi is 0. Sine of 0 is 0. So that simplifies everything. We get pi over 4 plus 1/2 times 0. That's just going to be 0 minus 0. So the answer is pi over 4. So what we have shown is the definite integral from 0 to pi over 2 cosine squared x dx is equal to pi over 4. Now let's look at a more difficult example where we have a higher power of x. Here we have integral of cosine to the 4th x dx. The first thing we will do is rewrite this integrand as cosine squared x all squared dx. Now we're going to apply the half-angle identity for cosine squared. So we have integral cosine squared is 1/2 1 plus cos 2x, all of this squared. Now let's simplify the integrand. 1/2 squared is just going to give us 1/4. We pull that right out of the integral because it's a constant. We get 1/4 1 plus cosine 2x all squared. Now let's fold out the integrand and simplify. We get 1/4 integral. 1 squared is 1. And we take twice these two terms, so it's 2 times 1 times 2 times 1 times cosine 2x. That's going to give us 2 cosine 2x plus, and square this term, we get cosine squared of 2x. Now you can see we have another cosine squared, so we have to reapply the half-angle identity. But notice that there is a 2-to-1 relationship. When this is x, here we have 2x. That means when we have 2x here, we have cosine squared 2x, we're going to have 4x here. So let's rewrite the integrand. That's going to give us 1/4 integral 1 plus 2 cosine 2x plus 1/2 1 plus cosine 4x. Let me erase this. I'll put it back in. 1 plus cosine 4x dx. So we applied the half-angle identity. Cosine squared x, cosine squared, I should say 2x, is equal to 1/2 1 plus cosine 4x. So there's a 2-to-1 relationship. When this is 2, this is 4. Alright, so what we have is we simplify everything. We get 1/4 integral 1 plus 2 cosine 2x. Distributing the 1/2, we get plus 1/2 plus 1/2 times cosine 4x, we get 1/2 cosine 4x all integrated with respect to x. Now we simplify the integrand more. We add the 1 to the 1/2. 1 plus 1/2 is 3/2. Let's do that on the next page. So we have 1/4 integral 3/2 plus 2 cosine 2x plus 1/2 cosine 4x dx. So what we have is 1/4. Let's integrate. Integral of 3/2 is going to be 3 over 2 times x. Integral of cosine 2x, we reverse the chain rule. We get 2 times sine 2x divided by 2. That's just the substitution rule or reversing the chain rule. For the same reason, we're going to get integral of cosine 4x is going to be sine of 4x divided by 4 plus c. So let's simplify the answer. We get 3 over 8 times x. Well, 2 over 2, that just cancels out. We get 1/4 sine 2x plus 2 times 4 is going to be 8 times 4 in the front. That's going to be 1 over 32 sine 4x plus c. So what we have is integral of cosine to the 4th x dx is what we have above. Now let's talk a little bit about this substitution that we've used a couple of times here. So what we have is integral of cosine kx dx. We do a linear substitution. We let t be equal to kx. dt, the derivative will be k dx. Divide both sides by k. We get 1 over k dt is equal to dx. So let's show that in full. We have integral cosine kx dx. We let t be equal to kx. dt is equal to k dx. That's taking a derivative of kx. Now divide by k, and we get dx is 1 over k dt. Let's transform the integral. We have integral cosine of t, because this part is our substitution t, and this part dx is 1 over k dt. 1 over k dt. 1 over k is a constant, passes through the integral. So we get 1 over k integral cosine t dt. When we integrate cosine t, we're just going to get sine. What is the antiderivative of cosine t? That's going to be sine. So 1 over k sine t plus c. We substitute t back in. T is equal to kx. So t is equal to kx. Let's plug that back in. And we get 1 over k sine of kx plus c. So that's the substitution that we were doing in the question, but we kind of did a shortcut because it was easy. We were able to do that mentally in our head. All right, thanks.